everyone. Good evening. I am very happy and excited to see all of you here at this Cisco Live Vegas 2023. So welcome to this breakout session where we will talk about firepower cluster NAT and PAT, operation and troubleshooting. And before we begin, I would like to ask you a couple of questions. The first one, can you please raise your hand if you are using NAT or PAT in cluster? Okay, great. I do see quite a few hands. And how many of you have run into any issue which in the end it was related to how dynamic PAT operates in clusters environment? Let's say PAT exhaustion, PAT pool address imbalance. Okay, I do see quite a few hands raised. And for those of you who didn't raise your hand, do not worry, because you are still in the right session. Because my main message for this session is that by understanding how dynamic PAT operates in a cluster, we could avoid running into low performance and avoid limiting the cluster throughput. So let's see what we have in the agenda that aligns with this main message. First, we will start by the basics. We will start by covering the multiple NAT types that we can configure in secure firewall devices, irrespective of the implementation. It could be a standalone, failover, or clusters environment. And then we will focus on how dynamic PAT operates in clusters. And here you may have noticed that I have divided this section into 3 parts. And the reason for this is that starting firewall 6.7, the way dynamic PAT operates changed compared with earlier versions. So first we will start by talking how it works in firewall 6.6 and earlier. And then we will cover the major changes. And by the end of this section, we will talk about a couple of enhancements that were added in firewall 7.0. Next, we will move to the troubleshooting walkthrough section, where we will cover the most common issues that we receive in TAG related to how dynamic PAT operates in clusters. And by the last part of this section, I have to admit, this is my favorite part because as engineer, I always like to see on a lab, how it works, all what I learned in the theory. So in this part, I'm gonna show you 2 things. The first one, I will show you the most useful troubleshooting commands that we can use to identify an issue with dynamic PAT. And the second one, I will show you on live how it operates starting firewall 6.7. Indeed, I have a couple of scripts to generate multiple TCP UDP connections through the firewall in order to run this on live demonstration. In the conclusion part, I will share the key takeaways from the session. You will be able to address all your questions via the WebEx room that was created specifically for this session. To me, it is pretty important that all the content, all the material, and information that I share here is clear to you. So in case you have any question or comment, do not hesitate in reaching out to me via this WebEx room, which I will take care right after the session. In the meantime, my colleagues, engineers from TAG, are monitoring this WebEx room to answer any question that you have while I am presenting. And with that said, I should introduce myself. My name is Alejandra Paez, and I come from Venezuela. I was born and raised in Venezuela, and in 2015, I moved to Mexico City, where I started to work for the Cisco Mexico office. So my career journey within Cisco started more than 8 years ago, when I joined as a security technical engineer for the TAG team, specifically to the firewall TAG team. And since then, I have been working on troubleshooting both the Cisco Secure Firewall ASA and the Cisco Secure Firewall Threat Defense devices. And it is based on this knowledge that nowadays I am a security technical leader within the CX organization. This was just a little bit about myself. And before starting, I wanted to let you know that in Cisco, we are working on sensitizing our naming convention. And we are currently in a transition period. We are transitioning the word master to the word control, and the word slave to the word data. Indeed, most of our documentation has already been updated to reflect this new terminology. However, there are some CLI commands that are using the old master and slave. So for the purposes of this presentation, I will be referring to the control and data unit. And with that said, let's kick this session off. And let's start by covering the multiple NAT types that we can leverage in Cisco Secure Firewall devices, starting with a static NAT. A static NAT is also known as a one-to-one translation, because it creates a static translation or a fixed translation from a real IP address to a mapped IP address. So in this example here, the source IP address of the client IP will get translated to the mapped IP address when the traffic is destined to any host behind the outside interface. Something important to mention here is that a static NAT allows bidirectional connection initiation, which means that traffic can be created not only from inside to outside, but also from outside to inside. So if there is any host behind the outside interface that sends traffic with destination IP, the mapped IP, it will get translated to the client IP address. That is why this kind of NAT is commonly used when we want to publish a server on the internet. And we can use it with port address translation. If we want to translate a specific port, let's say port 80 or port 443. The second type of NAT is identity NAT. And with identity NAT, a real IP address gets translated to itself. That is why this kind of NAT is also known as NAT exemption, because it essentially bypasses NAT. So in this example, the source IP address of the client will get translated to the same IP address when the destination is the server IP located behind the DMZ interface. This kind of NAT is commonly used for site-to-site VPN where the real header doesn't need to be translated. Or you can also use this NAT when you are translating a subnet, but you want to exclude a small subset of IP addresses to get translated. Then you can use identity NAT for this small subset of IP addresses. The third type of NAT is dynamic NAT. And with dynamic NAT, a group of real IP addresses gets translated to usually a smaller group of IPs on a first-come, first-served basis. The disadvantage of using this kind of NAT is that if your mapped group of IP addresses contain fewer IPs than your real group of IP addresses, then you may run out of IPs for allocating translations, which will result in connectivity failures. So let's take a look at this example here. In this example, we are statically translating the traffic from the inside network to the mapped IP group. And this mapped IP group contains just two IP addresses, the 201.1 and the 201.2. And I'm going to be using this mapped IP group throughout the entire session. So in this case, when host A initiates a connection to the server, traffic from host A will get translated to the 201.1. When host B initiates a connection, traffic from host B will get translated to the 201.2. But now when host C initiates the connection will fail to be created because there are no more available IP addresses for allocating that translation. In order to avoid running into this scenario, then you can configure dynamic port address translation. And with dynamic port address translation, a group of real IP addresses gets translated to a single IP address by translating not only the source IP address of the packet, but also the source port to a unique port. The way we configure dynamic path is by selecting dynamic as the type option. And then we need to specify both the original source and the translated source. For this example, I'm using the mapped IP address as the translated source. So here we can see that all the traffic from the inside network will get translated to the same IP address in the outside. Now, notice that the map source port is not always the same as the real source port. And this is due to source port availability. By default, the firewall will always attempt to maintain the same port when allocating the translation. However, if that port is in use, which means there is another allocation using that port, then the firewall will have to choose for an available port within the same range as the source port. So each IP address that is used for a path has 3 port ranges. And the same can be confirmed if we run the command show NAT pool. From the show NAT pool command, we can see that the path IP has port ranges from 1 to 511, from 512 to 1023, and from 1024 to 65,000. And now let's take a look at this XLATE table here. In this XLATE table, we can see in the first XLATE entry that the traffic from the 10.10 will get translated to the same IP address in the outside. However, in the first entry, we can see that the map source port is the same as the real source port. And this is because when allocating the translation, that port was available. So the firewall used the same port for allocating the translation. In the second XLATE entry, we can see the map source port is not the same as the real source port. And this is because that port was in use, which, by the way, it was in use by the first XLATE entry. So the firewall had to choose for an available port within the same range as the source port. Now, when working with dynamic path with a single IP address, depending on the XLATE rates and how long the XLATEs live in the XLATE table, it is possible that we run into path exhaustion. Path exhaustion means that the firewall runs out of ports for allocating translations. When that happens, the firewall will generate a syslog. So in that case, we need to check if the source IP address and the destination IP address of the connections that are subjected to path are valid. We should also check the XLATE timers, if the XLATE timers are properly configured. And I'm going to be covering XLATE timers just a couple of slides ahead. So if that is okay, then you may need to add one more IP address for the firewall being able to handle the connections that are getting translated. And that is when we use a path pool. By default, when we use a path pool, the way the firewall works is that it will allocate all the ports for an IP address within a range before moving on to the next IP address. But this behavior can be modified if we use any of the path pool advanced options. And that is exactly what we will talk in the next section. So in this section, we will talk about the multiple path pool options that we can leverage in Cisco secure firewall devices. Starting with round robin. When we work with the round robin keyword, the firewall will assign an IP address and a port from each path address in the pool before returning to use the first address again. The way we configure round robin is by going to the path pool tab and enabling the round robin option. When deployed, we can see here the NAT statement. We can see the dynamic keyword because this is a dynamic path, but we are using a path pool of addresses in a round robin fashion. So the way it works is that when host A initiates a connection to the server in the outside, traffic from host A will get translated to the 201.1. When host B initiates the connection, traffic from host B will get translated to the 201.2. And when host C initiates the connection, then traffic from host C will get translated back to the first IP address within the path pool, which is the 201.1. And this is because when we work with the round robin keyword, the path pool is treated as a circular data structure. The second path pool option that we will talk is flat. And I want to make a special highlight here, because flat is highly related to how dynamic path operates in clusters starting firewall 6.7. So when using the flat keyword, the path exlates are built by using the ephemeral port range from 1024 to 65,000, regardless of the source port of the packet. The way we configure flat is similar to what we did with round robin. And now when we run the command show NAT pool, we can see that the path IP address is divided into two port ranges, from 1 to 1023 and from 1024 to 65,000. And this can be expanded to use the entire port range from 1 to 65,000 if we use the flat keyword along with the include reserve keyword. Indeed, when you enable these two keywords together, now you can see that the show NAT pool is showing one big port range per path IP address from 1 to 65,000. The last path pool option that we will cover is the block allocation. And block allocation is also known as carrier-grade NAT. When we use the block allocation keyword, the firewall will allocate a block of ports per host. And depending on how it is configured, it could allocate another block of ports for the same host. Now, when working with dynamic path, it is important to understand how the connections are terminated or how the connections are removed from the XLATE table. And for this, there are two ways to do it. First, we have multi-session path. And with multi-session path, the XLATE will be removed from the XLATE table 30 seconds after the connection closes. And 30 seconds is the default value. This value can be modified. So the way it works is that let's suppose that we have a connection entry in the connection table. And this connection has an XLATE entry associated to it. When the connection closes, this connection is immediately removed from the connection table, but the XLATE will remain in the XLATE table for 30 more seconds until it is finally removed. On the other hand, we have per session path. And with per session path, the XLATE is immediately removed from the XLATE table as soon as the connection closes. Then again, let's refer to the same example. If we have a connection, and this connection has an X-late entry associated to it, as soon as the connection closes, the connection is removed from the connection table, and the X-late will also be removed from the X-late table. So we can say that paired session path will improve the scalability of path. And by default, all TCP and UDP 53 uses paired session path. And the same can be confirmed if we run the command show run all X-late. All the traffic hitting an X-late statement with a permit action will use paired session path, while the traffic hitting an X-late statement with a deny action will use multi-session path. And the same can also be confirmed from the show connection table. In the connection table, if the connection has a lower X flag, that means the connection is using paired session path. Now, with all of this background, let's jump right into how dynamic path operates in clusters environment. And as mentioned, starting firewall 6.7, the way dynamic path operates changed. So let's start by talking how it works in firewall 6.6 and the limitations that we have in firewall 6.6 and earlier. In a global environment, in a control environment, we have two global roles. We have the control unit and the data unit. And the control unit is the one that will divide each IP address within a path pool into all the nodes in the cluster. And thanks to the paired session feature that we just discussed, each node will be able to own an IP address and to allocate translations using that IP address. So for hit and run traffic, such as HTTP or HTTPS, paired session path will dramatically increase the connection rate per path IP address, while the traffic that is using multi-session path will be forwarded and owned just by the control unit. So when working with dynamic path in clusters environment, it is important that we consider a path pool of size at least equal to the number of nodes in the cluster, at least. Otherwise, we may limit the cluster throughput, or we may run into low performance. The way we configure dynamic path is exactly the same as we have discussed. And we can use the command show NAT pool cluster to see which IP address is owned per unit in the cluster. And we can also see here the backup unit of that IP address. And this backup unit will take relevance when a unit leaves the cluster. So when a unit leaves the cluster, the control unit will assign the path IP address, or the path IP address that was assigned to that unit will be rebalanced to another unit in the cluster. And when new units join the cluster, or when the failed unit rejoin the cluster, then the control unit will attempt to find an available IP address to assign this IP address to the new unit joining the cluster. Problem comes when there are no available IP addresses. And with available IP addresses, I mean IP addresses that do not have any port allocated. So when there are no available IP addresses, the control unit will not assign an IP address to the new data unit. And this is when we run into path pool addresses imbalance. And I'm going to be covering this scenario in details in the troubleshooting walkthrough section. So in a perfect scenario, if there are available IP address, then the control unit will assign an IP address to the new unit joining the cluster. So with this model of operation, we can say that we have a couple of limitations. The first one, the cluster path pool must be of size at least equal to the number of nodes in the cluster. Otherwise, we may impact the performance. The second one, the path pool distribution could become imbalanced as new units join the cluster or as units leave the cluster. And the third one is the lack of IP stickiness. And with IP stickiness, I mean the ability to translate multiple connections from the same host to the same IP address. Because the way it works is that, let's suppose that we have a client machine, and this client machine is generating multiple connections. These connections are going to be load balanced by the switch across all the units in the cluster. So each unit will take ownership of those connections and will use its own IP address for allocating translations, which will result in traffic coming from the same host getting translated to different IP addresses. And this doesn't work very well with multi-sessions applications. And I'm going to be covering multi-sessions applications in detail in the troubleshooting walkthrough section. So in order to overcome all of these challenges, starting firewall 6.7, a couple of enhancements or changes were introduced. The first one, the controller unit will divide each IP address in the path pool into equal size of port blocks. And it will evenly distribute these port blocks across the cluster units. So in this example here, we can see that each unit in the cluster will partially own an IP address from the path pool. So the way it works is that if a node receives a new connection that is subjected to path, the node will allocate a free port from the first block available. And it will do the same for each new connection that is subjected to path. When that port block is exhausted, then the node will move to the next port block. And typically, dynamic path is used for short-lived connections. So the probability of getting a port block free in a shorter time is higher. And the second major change that was introduced is that now flat is the default behavior. So XLATEs are going to be built by using the ephemeral port range from 1024 to 65,000. And this can be expanded if we use or if we enable the include reserve keyword. The configuration is going to be the same that we have discussed, but the difference is that now we don't need to enable the flat port range option because that is the default behavior starting firewall 6.7. So even though we don't see the flat keyword in the NAT statement, that is the default behavior. And now from this output, from the show NAT pool cluster output, we can see three things. The first one, port allocation will start at 1024. This is flat. The second one, the first group of port blocks are owned by one unit, and the second group of port blocks are owned by another unit. And each port block has an owner and a backup. And with this new model of operation, IP stickiness is now achievable, because each unit in the node will use a stickiness algorithm to determine the IP address to be used to translate traffic from a specific host. So if a host is generating multiple connections, then each unit will use the stickiness algorithm to determine what is the IP address to translate the traffic coming from that host. The only exception would be if that sticky IP address is exhausted. If it is exhausted, then the firewall will choose another IP address for allocating the translations. So we can summarize these enhancements in the following list. The first one is that now, starting firewall 6.7, we have the ability to work with a single IP address. However, it is important to properly size the path pool, because otherwise we are going to run into path pool exhaustion. And the second one is that now cluster-wide IP stickiness is achievable. And more enhancements were introduced in firewall 7.0 in the way the port blocks are distributed across the cluster nodes to avoid running into port block imbalance distribution. The first enhancement is the introduction of the cluster member limit command. The cluster member limit command will indicate the maximum planned number of nodes in the cluster. By default, this command is set to 16 by default. So if you are planning to have a cluster formed by 5 units, then you must properly configure this command to 5. And when the current cluster members is equal to the cluster member limit, then the cluster is marked as full. And you may be wondering, what is the importance of this subcommand? Or how this subcommand is related to how the port blocks are distributed across the cluster nodes? And the answer to it is that this subcommand is highly related to how the control unit will reserve port blocks for new units when joining the cluster. And with that, I have introduced you to the second enhancement in this version, which is the port blocks reservation. If there are n units in the cluster, control unit will reserve port blocks for n+1 until the cluster is marked as full. On a cluster that is just being brought up, the control unit will initially own 50% of the port blocks initially. And then it will redistribute these port blocks as new units join the cluster. And I know this concept can be kind of confusing. So let me use the following 2 examples to explain you how cluster member limit command works along with the port blocks reservation by the control unit. In the first example, we have a simple cluster setup. This cluster setup is going to be formed by 2 units. but so far we have just one unit in the cluster. And the cluster member limit is set by default. And now we know that even though we don't see the flat keyword in the NAT statement, flat is the default behavior. So XLates are going to be built from 1024 to 65,000. Having into consideration that each port block will have a size of 512, then we can say that we have 126 port blocks per path IP address. And initially, the control unit will own 50% of the port blocks. So control unit will own initially 63 port blocks. And this math can be confirmed with the show NAT pool cluster summary command. From this command, we can see that each path IP address has 126 port blocks. Out of 126 port blocks, 63 port blocks are owned by the control unit. And 63 port blocks are reserved. Now, when the data unit joins the cluster, this output changes. Now we can see that out of 126 port blocks, 42 port blocks are owned by unit 11. 42 port blocks are owned by unit 21. And 42 port blocks are marked as reserved, so the cluster will not use 42 port blocks for allocating translations. And this is because the cluster member limit command is set by default. So the control unit is expecting 14 more units to join the cluster. So control unit is reserving 42 port blocks for the new units when they join the cluster. And that is the importance of the cluster member limit command. Now let's take a look in the second example. In the second example, we can see that cluster member limit is configured to 2. And initially, this output is going to be the same initially. But then when the data unit joins the cluster, this output changes. Because now we can see that out of 126, 63 port blocks are owned by unit 11. 63 port blocks are owned by unit 21. And 0 port blocks are reserved. So the firewall will use all the port blocks for allocating translations. And the third enhancement that was introduced in this version is the port blocks reclamation. And the thing is that as units leave the cluster, or as units join the cluster, we could run into port block distribution imbalanced. So now the control unit will mark the excess ports, will reclaim the excess ports. So these units that have port marked as reclaimed will be unable to allocate new connections in these port blocks. When the port blocks get free, then those units will have to return the port blocks to the control unit. And the control unit will reserve those port blocks for new units when joining the cluster. So, for example, in this output, we can see that for the first path IP address, 126 port blocks are owned by unit 11. Sorry, out of 126 port blocks, 80 port blocks are owned by unit 11. And 46 port blocks are owned by Unit 2.1. So Unit 1.1 is owning more port blocks than the Unit 2.1. And here we can see that 17 port blocks are marked as reclaimed by the control unit. So now, when you run the command show NAT pool IP detail, you can see which port blocks are marked as reclaimed by the control unit with the hashtag. So we can summarize the list of enhancements in this version in the following table. Starting firewall 7.0, we have improved the path IP address port block redistribution to avoid running into port block imbalance with the introduction of the cluster member limit command, the port blocks reservation, and the port blocks reclamation. And with that said, let's move to the troubleshooting walkthrough scenario. In the first scenario, we have a cluster formed by 2 units. And this cluster has a path pool configured with a single IP address, which is something common. Now, this scenario can be divided into 2 sub-scenarios. The first one, let's suppose that a connection is load balanced across the control unit. So when the control unit receives the first packet of that connection, the control unit will take ownership of that connection. If that connection is subjected to path, then the control unit will use the IP address for allocating translation. So I would say this is a good scenario. Problem comes when the connection is balanced to another unit in the cluster. When the connection is balanced to the data unit in the cluster. Because when the connection is balanced to the data unit will take ownership of that connection. And then data unit needs to translate that connection. The thing is that data unit doesn't own an IP address for allocating translations. So when that happens, data unit will forward the traffic to the control unit for translating the connection. And this is just a simple scenario formed by 2 units. But we know that there are cases where we have 4, 6, 8 units in the cluster. Here is where we could impact the CCL link and where we could cause low performance in the cluster. So the mitigation would be to apply the best practice, which would be to ensure that we have a path pool size equal to the number of nodes in the cluster. The second scenario, multi-session connections. And the thing is that nowadays, a lot of applications are using multi-sessions. Web banking applications are using multi-sessions applications. And these applications sometimes use the source IP address or they use the user IP address to authenticate the user. So in a firewall cluster running 6.6 or earlier, this could be a problem, and this is why. Let's suppose that this host initiates a connection to any of these applications. And this connection gets load balanced across 1 unit in the cluster. In this case, the connection goes through the control unit. So the control unit will use its own IP address for translating the traffic. And now, the second session gets load balanced across another unit in the cluster. For this example, it goes through the data unit. When this second session goes through the data unit will use its own IP address for allocating the translations, which will result in traffic coming from the same user getting translated to multiple IP addresses. So the server will fail to authenticate the user, and the connection will error out. And the thing is that these kind of issues are intermittent, because sometimes it works, sometimes it doesn't work. And the reason for this is because sometimes both connections can be load balanced across the same unit. When those connections go through the same unit, then the traffic will get translated to the same IP address. But when the connections get load balanced across multiple units, then that traffic will get translated to multiple IP addresses. And here is where we have a problem. So the mitigation in firewall 6.6 and earlier is kind of limited, because one way would be to configure a static NAT for a specific destination IP addresses, but we all know that this is not something scalable. We cannot configure a static NAT for each destination IP address. We don't even know all the IP addresses of the server. The best would be to upgrade the devices to 6.7 or higher, because starting 6.7, we support IP stickiness. So now, if a connection goes through one unit in the cluster, that connection or the unit will run the stickiness algorithm. And the unit will determine the traffic from that host will get translated to one IP address, in this case, the 201.1. When the connection goes through a different unit, then the same will happen. The unit will run the stickiness algorithm, and it will determine that the 201.1 will be used for translating the traffic, which will result in traffic coming from the same host getting translated to the same IP address, regardless of the unit in the cluster processing that connection. And the third scenario is the path IP allocation becomes imbalanced. So initially, in a cluster running 6.6 or earlier, we have the path pool distributed across the units. So in this example, the path pool is formed by two units, by two IP addresses, sorry. And initially, these IP addresses are distributed across the cluster units. Now, if something happens in any of the data units, the data unit leaves the cluster. So the IP address that was assigned to that unit will be rebalanced to another unit in the cluster. So this new unit will take ownership of the X-lates and will continue processing traffic. Problem comes when the unit rejoins the cluster and there are no available IP addresses. Because when there are no available IP addresses, the unit will not own an IP address for allocating translation. The unit will be able to join, will be able to process traffic. The thing is that if the traffic is subjected to path, then the new unit will forward that traffic to the control unit for allocating translations. In this case, the mitigation would be, first, could be to add more IP addresses to the path pool. But sometimes we know that this is not something possible. If we are working with public IP addresses, sometimes we know that we do not have more IP addresses to add it to the path pool. The second one would be to clear X-lates for one address in the pool. But this will cause traffic interruption. So the best would be to schedule a maintenance window for clearing X-lates. So in this way, as soon as you clear the X-lates, the IP address will get assigned to the new unit that joined the cluster. This is for a cluster running 6.6 or earlier, because this changed on 6.7 with the port blocks reservation and reclamation. Now, we have approached to my favorite part, which is the demo section. In the first part, I will show you the general cluster configuration, and I will show you the troubleshooting commands. This is what I have in the lab. I have 2 firepowers, 9300. Each firepower has 2 security modules, and I'm running secure firewall threat defense in each security module. So I have a cluster formed by 4 units. The client is in the 10.4.1.0 subnet, and the server is located in the 10.4.2.0 subnet. So allow me 1 minute to connect to the units. Okay, so let me share this screen. Okay, so initially, my cluster is formed by 3 units. And the same can be seen here, master and slave, because I have intentionally left one unit out of the cluster. So what I'm going to do is that I will enable clustering in this unit. And in the meantime, I will collect a couple of outputs here. The first one, the show NAT detail command. The show run NAT statement. And the show NAT pull cluster summary command. Okay. So this is how my NAT statement looks like. I have NAT from inside to outside dynamic. I am NATing the inside network to the mapped IP group. And this mapped IP group contains 4 IP addresses, the 201.1, the 201.2, the 201.3, and the 201.4. So initially, this is how the port blocks are redistributed across the cluster nodes. Here we can see that out of 126 port blocks per path IP address, 32 port blocks are owned by Unit 11. 31 port blocks are owned by Unit 12. 0 port blocks are owned by Unit 21. And 32 port blocks are owned by Unit 22. And 31 port blocks are marked as reserved. And this is because the cluster member limit command is set to 4. And the same can be confirmed if we run the command show cluster info. So from the show cluster info, we can see the cluster member limit is 4. And the same from the show run cluster. From here, we can see the cluster member limit is 4. So the firewall is reserving ports for another unit when it joins the cluster. Now, let's check if the other unit joined the cluster. So now we can see the unit has successfully joined the cluster. The output is going to be different, show NAT pull cluster summary. From here, we can see that now we have 0 port blocks reserved. And those port blocks have been assigned to the new unit. And now let's move on to the second part of this demo. In the second part, I will show you the multiple TCP. I will show you how IP stickiness works based on below traffic profile. First one, with multiple TCP connections. Second one, with multiple TCP connections from multiple hosts. And the third one with multiple UDP connections. So going back to the unit, I will proceed to clear the screen here, and I will connect to my client machine to generate multiple connections, and I will leave the show con long command running. So with the show con long, I want to see the real IP address and the translated IP address of each connection. And now I'm going to generate the sessions. Okay, so from here, we can see that traffic coming from the 10.4.1.2 will get translated to the 201.4 IP address. And this, if we check in a different unit, for example, the unit 2.1, we can see the same. Traffic coming from the 10.4.1.2 will get translated to the 201.4. So it doesn't matter which unit owns the connection. It will get translated to the same IP address. And the same if we run the command cluster exec show NAT pool. And I'm going to run the command cluster exec show NAT pool IP 209.165.201.4 detail. Now let's analyze what we have here. The show NAT pool will show you how many ports are allocated per path IP address. So in this case, the unit 1.1 has 4 ports allocated. The unit 1.2 has 6 ports allocated. The unit 2.1 has 4, and the 2.2 has 6 units. And with the detail command, we can see which unit is the owner and which unit is the backup of those port blocks. So in this case, we can see the unit 1.2 is the owner for 6 ports. But the unit 2.2 is the backup of those port blocks because it has the star. A star means that unit is the backup for those port blocks. And now let's generate TCP connections from multiple hosts. For that, I'm going to run the script again, and I will run the command running. Okay, so the same. Now let's select another IP address within the cluster. If we analyze the traffic coming from the 10.4.1.5 IP address, the traffic coming from this host will get translated to the 201.1 IP address. If we check in a different unit, we are going to see the same behavior. Traffic coming from the 10.4.1.5 will get translated to the same IP address in the outside. For example, for the unit 2.1, it is getting translated to the 201.1 IP address. So it doesn't matter which unit process the traffic, it will get translated to the same IP address. And if we run the command cluster exec show NAT pool, then we can see the ports that are allocated per path IP address. And now I'm going to generate multiple UDP connections to show you how it works with UDP traffic. So I will leave the command running, and let me enable here the server. Just 1 minute. And I will run the command again. I'm going to clear a screen here, and I will generate these UDP sessions. Okay, so from this output, we can see that, remember, UDP is multi-session. All multi-session traffic will be owned by the control unit. So in this case, we can see that UDP traffic is translated to the same IP address in the outside interface. In this case, we are generating traffic from 10.4.1.2, which is getting translated to the 201.4 IP address. Now let's analyze the show NAT pool. With the show NAT pool command, and the show NAT pool IP 209.165.201.4 detail command. Let's analyze this command in detail. So from this output, we can see that for UDP traffic coming from the 201.4 in the control unit, we have 10 ports allocated. In the rest of the units, we don't have UDP. Here, this unit has UDP sessions, but now let's analyze what this means from the show NAT pool IP detail. So using the detail command, we can see the control unit owns the 10 ports from the UDP traffic. And the unit 21 is the backup unit. We can see here the star, which means the connections are owned by the control unit, and another unit will be the backup. And with that said, let's go back to the presentation. So with this demo, we can see how IP stickiness works in the cluster. And getting to the conclusion part, we have discussed that in firewall 6.6 and earlier, we had a couple of limitations. The first one, the path pool size. The second one, the path pool redistribution becomes imbalanced. And the third one is the lack of IP stickiness. All of these limitations were addressed in 6.7 and higher. With the port blocks distribution, with the cluster member limit command, the port blocks reservation, and the port blocks reclamation. So with that said, I want to recall my main message. By understanding how dynamic path works, we could avoid running into low performance or avoid limiting the cluster throughput. And with that said, I want to invite you to complete the survey session. Your comments and input are pretty important for me. Indeed, the last year, you let me know that you wanted to see a demo for this section. And that is exactly what I have done for this year. I have added a demo section to show you how dynamic path operates in clusters environment. So this is a win-win situation. You will win or you will earn some points, and I will get your input on your feedback about the session. I want to also invite you to continue with the education, with all the sessions that we have in the Cisco Live. There is a lot of work behind the Cisco Live. Want to invite you to assist to the sessions that will be delivered by the Technical Solutions Clinic. There are a lot of good sessions from engineers focused on troubleshooting. Indeed, this Thursday at 10 a.m., we'll have a session about clustering and common issues in clustering. So I invite you to assist the session this Thursday. And with that said, my name is Alejandra Paez, and I see you the next time. Thank you.